If you've ever wondered how Netflix recommends movies, how your phone recognizes faces, or how spam emails are filtered, you're already seeing machine learning in action. Welcome to this beginner-friendly foundation class here on Grow Your Life with AI. This video is designed for absolute beginners. No coding required, no complex math, just clear explanations, easy examples, and step-by-step thinking. By the end, you will understand the big picture of machine learning, and you'll be able to explain it in your own words. Pause when I say exercise. Take notes. Even one sentence per section is powerful. At the end of each part, we'll do a quick recap. Segment 1, Supervised Learning. What you will learn. What supervised means. Two types, classification and regression. Why starting with baselines is key. Explanation. Think of a teacher helping a child with flashcards. The teacher shows a card. This is a cat. Another card. This is a dog. After enough examples, the child learns the difference. Supervised learning works the same way. You give the computer labeled examples, and it learns to predict labels for new things. Example, spam filter in Gmail. We show the computer, this email is spam, this email is safe. After training, it predicts where your next email belongs. Micro exercise. Pause now. Write down a task in your life where you'd love an assistant. Could be sort my photos, suggest recipes, or screen resumes. Then write input, process, output. Pitfalls. If we give too few examples, the computer guesses badly. If we give biased examples, it repeats our bias. Ethics. Ask, who could be harmed if the predictions are wrong? Quiz. Question. Training accuracy is high, but new data accuracy is low. What's happening? Answer, overfitting. Mini recap. Supervised learning equals learning from labeled examples. Segment 2, Unsupervised learning. What you will learn. Grouping without a teacher, clustering basics, real life uses, explanation. Imagine opening your closet and grouping clothes not by labels, but just by similarity. Colors together, fabrics together, styles together. That's unsupervised learning. The computer looks for patterns without being told what the groups mean. Example, Spotify groups songs into playlists without knowing your taste directly, just by clustering similar audio patterns. Micro exercise. Think about your photos gallery. How could AI group them without labels, by faces, by colors, by places? Pitfalls. Sometimes, clusters don't make sense to humans. Ethics. Grouping people by data can lead to stereotypes. Be mindful. Mini recap. Unsupervised equals the computer organizes, without labels. Segment 3. Train, validate, iterate. What you will learn. Learning curves. Hyperparameters explained simply. Overfitting versus underfitting. Explanation. Think of preparing for an exam. You study, train, take practice tests, validate, and improve your study method, iterate. Machine learning works the same way. Example, imagine building a spam filter. At first, it misses many spam emails. You adjust by adding features like contains lottery words. Then you test again. Over time, it improves. Micro exercise. Draw two curves in your notebook. One for training error, one for validation error. How do they move together? Pitfalls. Only testing on training data equals false confidence. Ignoring validation results equals big mistakes. Ethics. If you skip validation, who is harmed when the model fails in the real world? Quiz. If both training and validation errors are high, what's happening? Answer: underfitting. Mini recap: train, validate, iterate. Feedback loop for better models. Segment 4: feature engineering. What you will learn: ratios and aggregates, avoiding leakage, scaling up features. Explanation: features are like ingredients in cooking. Choosing the right ones makes the recipe work. Bad ones ruin it. Example: predicting house prices, useful features, number of bedrooms, square footage, location. Useless features: color of the mailbox, micro exercise. Think of predicting student grades. Write down 3 features that might help: attendance, study hours, past performance. Pitfalls: leakage equals accidentally using future info. For example, using final exam score to predict grades. That's cheating. Ethics: be careful not to use private or sensitive features like race or gender unless there's a strong, fair reason. Quiz. Why is feature scaling important? To keep all features balanced when models compare them. Mini recap: better features equals better models. Garbage in equals garbage out. Segment 5: regularization. What you will learn: shrinkage, early stopping, dropout mindset. Explanation: regularization means keeping the model humble. It prevents overfitting. Example: think of a student preparing for exams. Memorizing every sentence equals overfitting. Learning the key concepts equals generalization. Regularization encourages concept learning. Micro exercise. Take your spam filter example. Which features would you shrink to avoid overdependence? Pitfalls. Without regularization, the model becomes too confident in noise. Ethics. An overfit model may discriminate unfairly because it memorizes patterns from biased data. Quiz. What is early stopping? Pausing training before the model memorizes too much. Mini recap. Regularization equals teaching the model not to memorize but to generalize. Segment 6: model families. What you will learn: linear models, trees and ensembles, KNN and SVM basics. Explanation: different problems need different tools. Models are like tools in a toolbox. Example: linear model equals straight line for predicting house price by square footage. Decision tree equals flowchart for deciding loan approval. Ensemble equals many small models voting together. KNN equals asking your neighbors for advice. SVM equals drawing a boundary between two groups. Micro exercise. Write down a real world decision. Should I buy this product? What model family could represent it best? Pitfalls: using the wrong model for the wrong task. Ethics: some models are black boxes, making it hard to justify decisions. Quiz. Which model is easiest to explain to beginners? Decision trees. Mini recap. Models equals different tools. Choose the right one for the job. Segment 7: pipelines. What you will learn: reproducible steps, fit versus transform. Sanity checks. Explanation: a pipeline is like a cooking recipe. Follow the same steps every time, so results are consistent. Example: data cleaning, feature scaling, model training, evaluation. Micro exercise. Write your daily routine as a pipeline. Wake up, brush teeth, breakfast, work. Pitfalls, skipping steps, or mixing them up. Ethics, pipelines ensure fairness because the same process applies to all data. Quiz, why are pipelines important? They keep processes reproducible and reliable. Mini recap, pipelines equals repeatable, trustworthy ML processes. Segment 8, AutoML and no code. What you will learn. Baselines, limits. Evaluating results, explanation. AutoML is like autopilot. It builds models for you, like great for beginners, but you must still check its work. Example, Google AutoML, teachable machine, drag and drop tools. Micro exercise, visit a no-code tool like teachable machine and try training a tiny model with your webcam. Pitfalls, blind trust in automation. AutoML may choose a model but not explain why. Ethics, be cautious. AutoML can hide bias inside black box results. Quiz, what's the main danger of AutoML? Over-reliance without understanding. Mini recap, AutoML equals great helper, but always check the output. Segment 9, case study, what you will learn, support ticket priority, feature planning, metric choice, ... explanation. Let's walk through a real project, predicting which support tickets are urgent. Example, inputs equals ticket text, features equals keywords like crash or urgent, output equals priority score. Micro exercise. Think of your own example, maybe predicting if a recipe is healthy or not. Pitfalls, choosing the wrong metric, like accuracy instead of recall. Ethics, who suffers if an urgent ticket is ignored? The customer. Quiz, which metric matters more for urgent ticket prediction? Recall. Mini recap, case studies show how theory turns into practice. Segment 10, Explainability 101. What you will learn, global versus local explanations, simple visualizations, communication trade-offs, explanation, explainability equals teaching, AEI to show its work. Example, a model predicts a loan rejection. Sharp values show which features influence the decision, like low income or short credit history. Micro exercise, pick one decision you made today. Explain the top 3 reasons behind it. Pitfalls, complex explanations confuse non-technical people, i.e., ethics. Transparency is key to trust. Without it, people may reject AI decisions. Quiz, which is easier to explain? A linear model or a deep neural network? Linear model. Mini recap, explainability builds trust in AI TED. Segment 11, deploy preview. What you will learn, monitoring basics, feedback loops. Explanation, training is like practicing at home. Deployment is performing on stage. The audience, real-world users, gives feedback. Example, Netflix model recommends movies in real time, while a weekly sales forecast model runs in batch mode. Micro exercise, write one task in your life you'd prefer real time and one task fine in batches. Pitfalls, forgetting to monitor drift. Models can go stale as data changes. Ethics, if we don't monitor, people may get unfair results for months. Quiz, what's concept drift? When the real world data changes and the model no longer matches reality. Mini recap, deployment equals the true test with monitoring and feedback. Segment 12. Action Plan. What you will learn. How to start small. Practice datasets ... Comparing baselines. Explanation. Now let's turn learning into doing. Example. Pick a dataset from Kaggle. Train 3 different models. Compare their performance. Micro exercise. Choose one dataset today. Write down your baseline idea. Pitfalls.